Welcome to the Virtual Foundry podcast.
Hi, everybody. Welcome to the Virtual Foundry podcast. This is volume 3, episode 14. Today is Monday, November 14th, 2022. The time is 1:08 p.m. and the temperature is a chilly 36 degrees. That's a whole 2 degrees for you Celsius users. Winter is upon us here in southern Wisconsin, but we're having some beautiful sunny days along with those cooler temperatures. And I like to say it's never cold when the sun is shining. So it's all right with me. Today, I'm going to be talking with Gordon LaPlante. He's the co-founder of gCreate, and he's been doing some really cool prints and some work with Filamet. So we're going to hear all about that today. Say hello, Gordon.
Hi, hello everyone.
And you had to tell us where you are and what the temperature is there.
Sure. So as you mentioned, my name is Gordon LaPlante. Our headquarters, gCreate, is in Brooklyn, New York, and right now it's 45, so it's a little bit warmer.
That is not a bad day.
Yeah.
The late fall as we're getting into some winter.
Exactly.
Now, Gordon, tell us a little bit about gCreate. You're making your own 3D printer.
Sure. Yeah. So gCreate, actually, we started on Kickstarter, actually just a few years before you guys were on Kickstarter, 2013, 2014. And we went to Kickstarter with a large format desktop 3D printer kit, because there really wasn't a market, or there's a market for it, but there really wasn't a printer to fulfill that need. So we started there, 8-9 years ago, and now we have our latest versions, the G-Max 2 Pro. Again, a large format desktop 3D printer. Our print volume is 18 by 18 by 24 inches. And within that volume, we can print very large things, but also tiny things and with high detail. So
great. Gordon, how did you get started with 3D printing?
Sure. So at the time, the RepRap kind of community was really taking off and getting much larger, and so that was the open source kind of 3D printer. And I actually built one for myself when I was studying to be an architect. So funny enough, I just finished getting my license, and then my partner and I decided to start a company building 3D printers because I built a larger one for myself and found, it actually worked out really well. And so that's basically how we got started.
Great. What made you then want to take the leap from plastic into the metals and work with Filamet?
So when I saw you on Kickstarter, I was really intrigued because metal has always been the kind of holy grail. Plastics are great and there's a lot of high performance plastics out there, but if you can truly do metal parts that you can then machine or whatever, post process without having to go to a foundry or things like that, that really was just what excited me. So we actually did the Filamet Kickstarter, and that's actually the bronze parts that I printed here and sintered. So it's a bit of an older spool, but yeah, that's something that we really we're interested in.
Yeah, version 1.
It was version 1. We also met you at IRF and Murph, I think, a few years back. So the copper actually is where we got a sample from you at, I think it was Murph 2019, I believe it was, or 18.
Yeah, I think that might have been all the way back in 2018.
Yeah.
Okay, well, let's hear about your work. Tell us all about the printing and the prints that you made.
Sure. So we started printing just some basic smaller objects. I started with the bronze, and I actually printed these several years ago, but I never had a kiln to actually sinter them. So I can show you some of the end results. Okay, so really one of the first prints we wanted to do out of the bronze, there was two. One was a phone holder that's an octopus phone holder, and I wanted this because the print had to travel far, so I would see if it was stringing or not. Plus, it had overhangs, and I didn't use any support, so I wanted to see how well it could handle, warping and things. And again, this is an earlier version of the Filamet, so it did string a lot, but the newer stuff doesn't string at all. So the second one was of course, I didn't capture any video footage of the printing because it was years ago, but the second one was a lion head kind of door knocker.
Yeah.
And this one too was much heavier. It was a lot of filament, maybe 100 grams, or I mean 300 grams. But this too I made the mistake of the two bronze parts by printing them with 90% infill instead of 100, and you'll see what the result of that was, especially on the lion head. But yeah, so those two parts were a lot of fun to print, and then because I was going to sinter the bronze, I went ahead and bought or got the copper and printed with the copper as well. So I actually have some video of that, which I can show real quick. The copper itself, as I mentioned, it was a string. It was a lot less stringing in the copper, but it still had some. So here's I printed this Medusa kind of medallion. And this too, because it was the older Filamet, it actually ended up clogging a few times because I was trying to get the settings just right.
Yeah.
So, but other than that, it actually printed really nicely. And I printed like a couple copper coins and things. So here you can kind of see a quick shot of it printing. This one was on our GMAX 2 Pro with the copper head. So it handles temperature much better. But that was a lot of fun to print those. All right. And then I also did, my favorite is the little T-Rex. I did like 10 different things because we figured if we're gonna go for it, we might as well print them, all at once.
Right. So what printing temperature did you use?
So these are all basically PLA settings, so around the 205 to 210, with very little cooling because it didn't really need the cooling.
Yeah.
I realized. So yeah, I didn't have to do anything special, even though we could have gone higher temp. So here's basically all the final parts we did. There was a kind of like this Pirates of the Caribbean coin, and then a just some sort of weird like door pole, and then the Medusa medallion. Yeah. So then from there, I obviously I followed your instructions to a T on the Virtual Foundry website for debinding and sintering, and they worked perfectly. We used a PMC desktop 3D or kiln.
Okay.
PMC, I think they're in the Hudson Valley here. I can show you a picture of that. So it has the programmable function, which is really necessary because yeah, you really had to follow that that program to a T, but it worked great. Of course, this was in my basement. But all right. So after the printing, and then I put it into. I actually got, not for the stainless steel, but for the copper and the bronze, I used a stainless steel camping crucible.
Yeah.
Because it was cheap. It's at Walmart, and it is stainless steel. So this is where I put in the talc. It fit my kiln just right, so it actually worked very well. And again, with the talc and the powders, you can reuse them. So I think I did both the bronze, 2 or 3 bronze prints together at the same debind, because the bronze and the copper have the same debind temperatures, which was actually nice. Yeah. So then from there, I know I'm jumping around here. I ended up debinding was totally fine for the. I actually put I put aluminum foil on top to try and prevent some of the oxidation, which it didn't really need. I don't know why I did it. Oh, hang on. And of course, it just flaked off, so it was pretty much pointless. I should have gotten stainless steel foil if I really wanted to do it. So then the prints themselves, the debinding, like I said, actually worked out totally fine. The medallion for the copper Medusa there, it actually broke apart once I was taking it out of the debind.
Yeah.
Unfortunately, it was a very small part, and it actually I knew it was going to kind of fail because I actually had a few clogs in it, and that was my settings. But I said, you know what, I'll go ahead and debind it and center it anyway. But in the end, it actually centered great. It was just in 4 parts.
Wow.
So those actually all came out great especially after doing the sintering process. So here's the lion head after the debind. And as I mentioned, because I did the 90% infill, which should have been 100, the whole center kind of the face kind of collapsed.
Oh, wow.
Slightly. And it was to be expected, especially considering, let me put it back up. The kind of, there you go. In the very center here, it collapsed because I had it sitting up. So whatever it did kind of not melt, but kind of warped straight down. I think if I put it upside down, it actually would have been fine because then the back would have been warped, and who cares? But all in all, I think it still came out great. And that was all the debinding and sintering of the copper and the bronze. So in the end, what I actually I washed it off in some water just to see if I can get the. Actually, I'm sorry, that was during the top. this is the debind process. I know I'm jumping around here, but so that's right after the copper debind, which actually came out great. Again, the parts, for as thin as they were, I'm surprised they didn't warp at all. I laid, put it flat on a table, and it was great. The only warping was that kind of bronze head that kind of melted in there. But yeah, so then I'll show you one last thing before I show them in person. The probably the most fun part in this entire process is something I saw on your website. So basically, I realized I was trying to polish them with just a little brush or whatever.
Yeah.
Well, I have a metal polishing wheel, and I saw it, I think, in one of your emails or something, and I said, "Wait, you can do that?" And the second you run it or polish it, it's immediately
Yeah.
it polishes so nice. So that's probably the most fun part of the entire process. Yeah, and then the same thing with the bronze. The bronze actually looks almost like brass when you polish it up.
Yeah, that
Which
is instant gratification.
it really is, especially after you've spent all that time trying to get it, finished. So the bronze itself looks very much again like kind of like a brass. And it was really cool. And this was probably everyone's favorite print because it weighs so much,
Yeah.
it feels like something substantial. So yeah, so there
Oh,
was
it looks like the detail stayed. It just kind of
all the
smushed
detail.
in.
Yeah, all the detail stayed there. It just didn't like obviously that center and even the teeth. I mean, I can't believe like all around the mane and everything. It was really neat. So with this part in particular, one thing I tried doing was face milling it because I wanted to see how solid it was in the back.
Yeah.
So let me go ahead and put this over here. So it actually does mill really nicely. Let me start it over again. This was probably the second pass. I went another maybe couple hundred microns, but no, it really, as I pause it here, you can see there was almost no voids whatsoever, maybe tiny minuscule voids once I got past that, the outside layer there. But no, this part it's a solid metal part. So it really worked exactly like I was hoping it would. So, and I'll go ahead and stop sharing real quick so you can see. So the parts themselves now, really, there's the back there that really milled beautifully. Again, probably the most fun part to hold. Another one that was really neat was with all this detail was a tiny T-Rex skull.
Oh, yeah.
And that's probably one of the most interesting ones because it actually kept all the teeth. It kept really everything, and it warped a little bit as you can kind of see from the front here. But all in all, I keep it on my keychain to show everyone I'm when I'm out and about. So these actually, and the same with this one also, you can kind of see the center there, how that warped down. Same thing, this is only the 90% fill, but otherwise the part itself is flat. There was no support, so it actually printed fine, and as far as debinding and sintering, this one has a little bit of some stress cracks. I'm not sure if that was may have been the debind process or right after printing, but otherwise it's a solid part. And again, they feel so good just to hold it and to show people. I did do
I've seen photos of that part several times and I always wondered what it was. So I'm glad to finally find out.
It was
phone holder.
I don't know why I picked it. It just your phone kind of just sits in here, and it was something we printed before, so I figured I would kind of compare it to a PLA print.
Well, I'll tell you what, no one else has one.
Exactly. I did do a can opener or bottle opener, but it's bronze, so it's not that strong. So I tried opening a bottle once or twice, and I think I almost broke it. So I said, I'll save it for the stainless steel maybe next time.
Yeah.
So that's the copper and kind of bronze parts. So the coin itself is super flat. This door pull or kind of like steampunky thing. Again, the detail was great. I did find that during the process, I think you guys mentioned it, cleaning up any of the parts, you do it right before the debind. And you can sand it or whatever. And actually one of the parts I sanded some of it to see how well it would look versus just polishing it when I was done. So you're right before the debind, I recommend people that's if you want to do any cleanup or do any fixing. I actually had one part that on the rocket that the foot broke off, and I actually was able to put it back on with some heat, and it still sintered fine. So it was enough just to keep it together. So it actually worked out great. So
yeah, we haven't talked about this very much, but prints can be repaired. It talks about you just applied some heat, but there's also the option of using a 3D pen,
Oh, right.
sort of weld a couple of parts together before sintering.
Yeah, because then, as long as you have those parts connected, the
Yes.
sintering will do the rest of it. We used to have a 3D pen here, or 3D pen here to fix prints in the same way, but I ran out. But yeah, no, definitely that definitely worked. I can show you. So between when we were talking before, I actually was able to finish the stainless steel parts, and that was the next kind of part of the process. So those are really exciting. I printed them last week and sintered them this weekend. So I can show real quick. I'm going to show you the slicing. So this is in Prusa Slicer, and it's just kind of a simple little bracket. There's no purpose to it other than just to kind of test overhangs and test fine detail, that sort of thing. And then my settings, as I mentioned, are pretty standard. 0.2 layer height, infill. This one, I did the infill at 100%, and I did a lot of perimeters, so it wasn't even infill, it was just all perimeters mainly. And then again, 205, 210 for the temperature for the printing itself. We actually don't use a lot of heated beds here. We do a lot of our printing on acrylic because there's really no need for certain parts, and especially with Filamet. If you put it onto acrylic, as you saw in some of the earlier photos, if you put it on acrylic with painter's tape, it's perfect because you're not going to have it stick to the acrylic too much, but also you can rip the tape off if you had to, if it was sticking too well. And that seemed to be a great combo. So these parts, let me go to my other tab. So the stainless steel, the second one I did was actually our gCreate rocket, as I mentioned, which is, it's kind of our logo from years ago. It's kind of a tricky print. It was actually supposed to be one of our like torture tests because you have small parts, you have overhangs, you have fine detail, and the whole inside is actually hollow. For this particular one, it's actually a money bank when you print it full size, so you can put coins in it.
Nice.
But it was fun because it's only 2 perimeters for the walls, maybe 3. So it's a pretty tricky part to print and then also center and bind. So as you can see, each layer here, it's really only 2 walls thick. So this one here actually printed great. Again, with the new Filamet, there was no stringing. I dialed it in a tiny bit and, maybe a few blobs here and there. And again, the overhangs here, there's no support or anything. So I'm really happy with how this one turned out. And it's probably.
Did you tell your slicer not to generate support, or did it do that? Did it not generate them on its own?
Yeah, I purposely said don't do it on both models, really. I just use Prusa Slicer, which I've been very happy with, especially for these parts. And if I did do support on the very bottom of the actual kind of like legs of the rocket, you can see how it drooped here. It's actually not that the filament failed, it's that it actually didn't connect. But other than that, the next layer right above, it bridges great. So this stuff, it printed fine. I didn't even need a filler warmer, especially for the newer, stainless steel, because it's great. It's so malleable that I really like it a lot.
So you're really seeing the difference between version 1 from the very beginning and what's happening now.
Yeah, it's a massive difference, and I'm not sure what the additives are in the newer stuff, but I mean, you can bend it, almost 90, well, let's say like 70 degrees, and it won't break. And it also may have been when I got the copper, it sat for several years, so maybe, or like a year or two, so maybe it just dried out or something. But no, this stuff was great. So that was the rocket printing. I had one fail, but that was because, again, it's such a very tricky model that one of the legs broke off. So I actually ended up just printing another one. So now I can show you. So that one, I same thing. It's the process for debinding and sintering the copper and the bronze is different because than the stainless steel. For the copper and bronze, you debind in one cycle, and then you do the actual sintering in a second cycle. And I realized with the stainless, it's all kind of one shot, which worked out. It was actually really nice. So for this particular one, I actually used a crucible, a graphite crucible.
Yes.
I know you mentioned, was it the alumina to get as far as a crucible?
Well, it definitely, for the steels, it needs to be something more hardy than stainless steel.
Yeah.
So alumina, graphite crucibles are great too.
Yeah, I felt like the graphite, it was very, very tight in my kiln. It actually was touching the top, which is probably not ideal. It did warp the kiln a tiny bit, but other than that, it worked great. So here you can see the prints themselves on the bottom, and then the crucible itself on the top there. Yeah, here we go. So again, these prints, so the bracket or whatever you want to call it here, on the back side of it, I actually sanded it a little bit to try and smooth it out. And then on the top, I didn't, because I wanted to see the difference, you know, if you could see the layers and everything. So this one, after sintering and debinding and sintering, it again, they came out great. You can see the parts, all the detail is there, all the layers you can see. So if you wanted to sand it, you could have before, but I purposely didn't. And it's same thing with the rocket, all the little you know, rivets or whatever are there. So I did have one mishap with the actual rocket. I'll show that in a second, but once they were done being debinded and sintered, I did do the wonderful polish again, which is so much fun. And it just shines, you know.
Oh, nice.
So the only problem I had with the rocket, which I think is in the next video, unfortunately, the legs on the bottom here, especially you can kind of see how weak they are. They actually broke off. I was being a little bit too strong with the polishing.
What?
Yeah, it's to be expected because it's such a small amount. And so for the actual stainless steel, I didn't I don't think I centered it hot enough. You mentioned 2250, and that's the high end of my kiln. So I actually did it only at 2200 for the 4 hours, the whole process following on the website. And I think that's why they broke off, because I don't think it truly centered just enough. It's still a solid part, but it's a fragile part. But I think if I let it go for either longer, or maybe if I did that extra 50 degrees, maybe it would have made a difference. So I guess that'll be the next. These are just tests, so I'm going to do a much larger print with the stainless steel next. But here you can see the final stainless steel parts came out great. I actually tried sanding the backside to see how kind of smooth I can get it. It's what's interesting. You can see this is actually like the layers themselves that didn't bind, I guess, together or center
Yeah.
together. So so the part itself is still solid, but there's a couple spots where it just didn't kind of get it. And I also did both the rocket and this at the same time, so maybe it was too close to a piece, or too close to the edge or something. But again, the rocket itself, in the end, I actually broke off all three of the the pieces. But I'll probably just epoxy them on. But other than that, the part itself, you can see all the detail, all the layers, everything came out great and
Oh, that looks great.
completely hollow inside. So yeah, I think it was a lot of fun, especially with the stainless, to really test. Here's the bottom little cone, but it actually has every bit of detail. So the last thing I have that I haven't quite tried yet, we've been discussing it, is the aluminum filament.
Yes.
And that's going to be interesting because of the oxidation.
Right.
And my kiln obviously has it's just an open air, well, not open air, but it's not a sealed kiln with the vacuum. So I'm gonna try it. I know was it Highball has been doing a lot of the sintering with it, and I've been watching.
Microwave sintering, yeah.
Exactly. So that's gonna be fun. It probably might be a little bit trickier, but
Are you going to try the microwave sintering method?
I might try it. I know that's actually something I looked into years ago before I got the kiln. I did what did he use for the actual crucible? He made his own with the filament.
He did. He uses a some kind of ceramic for the container part, and then he used the Virtual Foundry's silicon carbide
That's what it was.
filament and printed that in. They're available commercially, though, easily on Amazon. It's called a microwave kiln.
Right.
Container is. Yep.
I mean, it's something I might try. I do love that my kiln is so precise and programmable that you know what you're going to get as a result. And I know he's been doing so many experiments with trying to determine what the temperature really is and all that. But it might be a fun little project to test out.
Yeah.
What I really wanted to try, we have so our printers, we have the copperhead that can go up to 400 degrees, technically 450, which we don't need it for this, but we do have two dual extruder printers. And I would really like to try and find a way to do maybe copper and bronze, but I don't know how I would sinter without one of them truly melting,
Yeah. So if you want to sinter a piece with more than one material in it, you need to find where the sintering temperatures match up.
At least as close as you can. So, or I guess if you do it with because the copper, I believe, is the hotter temperature. If you sinter at the copper temperature, would the bronze evaporate? I mean, would it boil off? You
Well,
know,
let's
it's
see how much of a difference there is. We're talking about copper at 1925, bronze at 1625. So
it's a
maybe if you split the difference a little
yeah,
bit, bring that copper temp down maybe another 100 degrees. I don't know. I think the bronze probably will get into some melting territory, so you'll
yeah,
have a difference in shrink.
yeah. And if I can have it in such a way where maybe that part is contained, you know, so even if it does melt, it won't melt away. It'll just stay within the
Yeah.
bounds of whatever that part. That could be a fun little experiment next. And I still have, funny enough, a little bit of the bronze left from the first run there.
Oh my gosh, that is old timey school.
It's old timey. And then here's the copper that I had left. So because it broke so much, I actually had to keep feeding it to the printer piece by piece, which actually did work, funny enough. But here you can see all the small
Yeah.
slivers. So I kept it just in case, even if I wanted to melt this and put it in something, I can still, sinter it later. But I'll end up getting some more copper and bronze to try the dual.
Well, that'll be fun.
Yeah,
I look forward to seeing that as as you make that happen.
exactly. My father builds rat rod like kind of cars and trucks and stuff, and I 3D printed him some hood ornaments years ago, like a mermaid and some other things, but they're plastic. And so he said, "Wait, you can do metal now?" So I said, "If I can make him a bronze or even a copper hood ornament, he would go crazy."
Oh, fun. Yeah, that
Yeah,
would be great.
exactly. It's something he'll use. It's on his car. He drives it all over the place. So
Well, we can see here that you've carefully documented your process and you have taken that a step further and actually written a couple of articles or written about the process in two parts, two articles, lots of pictures, and lots of detail about your printing process and your debind and sinter process. And you've published both parts now. So those are out. Where can people read more about that?
yeah. So both parts are live. Part one is kind of the printing and kind of setup for the parts, and part two is debinding, sintering, and polishing. You can read them both at gCreate.com, and on the main page you'll see the articles if you scroll down a little bit. But yeah, there's settings in there. If you have the PMC kiln that I have, I wrote the program that we used. There's the timing and things like that. And there's a bunch of videos and pictures there as well.
And also at gcreate.com, that's where people are going to find out about your 3D printers.
Exactly. Yeah. gcreate.com. You can read all about our printers and see all of our specs. And then if you wanted to buy, you can go to shop.gcreate.com and order there. We're going to be having a Black Friday sale coming up, so you might want to keep an eye out and see what that is about. But yeah, we manufacture the printers in Brooklyn, New York. We ship all across the country, and yeah, we've been at this for several years.
You did all of this printing on the G-Max Pro.
So the bronze, because I did it a few years ago, was on a GMAX 2. One of the newer copper ones and some of the stainless steel is on the GMAX 2 Pro, which is our latest printer. And those were on the copperhead. And I think I did one on the 2-in-1 tool head, which is 2 inputs and 1 output, which is where I want to try and do the dual printing.
Well, Gordon, is there anything else that you would like to add before we wrap up today?
So I think we talked about this. Do you have any plans of doing brass? I think you said there
Oh
was an
gosh,
issue.
I know brass is a tricky material. We've tried it several times over the years. In fact, it was one of those that was going to be part of the triad in the very beginning, bronze, copper, brass. And that is one of the few rare materials that we've come across that just hasn't worked in our standard manufacturing process. So development continues on that one. It's become a personal mission now to get brass filament. So it'll happen someday, but I don't have any kind of timeline for you now.
Yeah, maybe I'll do some testing with it then when you start going
Yeah.
that far down. But I mean, the bronze itself, when you polish it, it actually looks like brass, so it's pretty funny. But no, it's been really enjoyable to print these and center them and hold them. So I really appreciate all you guys have done, especially because you're really pushing the metal 3D printing on desktop, and people can print it on a home printer, which is great.
Yeah, thank you for that.
Yeah.
Gordon, I do have one more very important question for you before we wrap up today.
What is it?
What does a cloud wear under its raincoat?
Oof. I don't know.
Thunderwear.
I love it.
Gordon, thank you so much for joining me on the podcast today. It was really great to talk with you in person. I don't get to talk in person with too many of our partner innovators, so it's always a special treat. So thank you very much for spending some time with me today.
Oh, same here. I really appreciate it, and I'm really happy that we were able to show off what we can do with the metal printing.
And thank you all out there for joining us on the podcast today. If you have a cool project you want to show off, like Gordon just did, reach out at info@thevirtualfoundry.com and we'll do a podcast with you. If you have a topic you'd like us to do a deep dive on, same place, info@thevirtualfoundry.com. We would love to do a podcast with or for you. And in the meantime, happy printing, everybody.